more. Okay?
Okay. Yeah.
Okay. And okay, you click 2D. Next,
Yeah.
you need electric currents
Mhm.
and heat transfer.
Yeah.
Next,
Mhm.
stationary.
Mhm.
Finish.
Mhm.
Then you get this.
Yeah. Yeah.
You
Change.
put this to millimeters.
Yeah.
That's the length of which you do.
Mhm.
What you do. Then you change your view.
Mhm.
Officially, it has to be -1, 1, -1, 1. It doesn't really matter that much. Then you look here. You can draw. Create, just create.
Yeah. Yeah.
Something like this. Put in this, like this
Yeah,
here,
yeah.
and no, we'll do it differently. This one here,
Mhm.
there. Right click, Boolean, difference.
Understand. Click.
Plus, click that,
Click. Yeah.
plus,
Click.
and plus.
Yeah.
Build it.
Mhm.
Done. Now we need to select the material.
Mhm.
Material
Yeah.
just
Copper.
just going to be copper.
Yeah.
Copper. It doesn't
we have
want
it.
us, but that's very simple. It's simply done. Electric currents. It doesn't really want us to do that yet. Just do that, and it'll say okay. You put in a temperature.
Yeah.
Temperature here, I want to be high, so I
Yeah.
100 degrees hotter. Temperature at that point, I want to have it normal.
Yeah.
Okay, we can compute this.
Yeah. Okay.
Now it'll just give us the temperature. If we do another 2D plot group with an arrow surface, and we will just do this. You can see now the heat, how it flows off the of our thingy.
Yeah.
How it flows towards our thing, even. That's what we're seeing now. Yep?
Yeah.
Okay. What we're now going to do is we're going to add physics. So we select our model, click add physics, and electric currents. Finish. At this point. Now, this is going to be our ground. This will be a 0 charge point. Now we're going to add an electric potential to here of 1 volt.
Yeah.
If we now calculate this again, we can calculate the resistive losses of this thing. So 2D plot group, we'll add a surface.
Delete.
Click. Well, you can change. Click this one, which is replace expression. Electric currents, heating and losses, resistive losses.
Yeah.
Plot this.
Yeah.
This thing and resistive losses. You can copy that. Put this in heat source towards there. This should be user defined. Copy.
Okay.
Copy it in there. Now the heat source should be our resistance. If you compute this, and now we look at the temperature, and you can see the temperature here is a lot higher.
Yeah.
Way higher, actually. It's nearly 18,000 Kelvin.
Ja.
Is goed.
Ja.
Alleen die cuvetjes moeten nog even...
In het ding.
Even, ik weet niet of gewoon nog extra schoongemaakt worden of niet.
Nee, die drogen zelf wel, dus.
Ja. En de UV-vis moet nog uit.
Oké.
Oké.
En voor de rest is het volgens mij wel klaar.
Ja.
See you tomorrow.
See you tomorrow.
Yeah,
Yeah,
tomorrow
the-
maybe. I'm with the second class lab.
Oké.
Klaar.
Ja.
Bye.
Bye.
Okay, now, as you can see, this thing here is way hotter. And that's actually the whole point.
Yeah.
And what you can also do is use a 1D plot group. But we'll get to that a little later, because this way is not really the way to actually do that. If you have the surface, for example the temperature surface, you can put in here the beginning of a measurement, and here the end. For example, like this.
Okay.
If you now wait, this is the second one. This, see? Then automatically there's a 1D plot group created with the temperature according to that line. So you can see, for example, here. If you click here.
Yeah.
Oh, well, you should get something here. But if you look at 0.4, the temperature is about 13,500. If we look at the temperature, and we look at, let's see, well, it should be around that color, so that's indeed around 0.4. If you click there, wait, oh, it still is that selected, sorry. Unselect that, deselect this. If you click here, it says this value.
Okay.
So we can just look around a bit and see where is our 13,500. Should be around here. 0.2, I started at around 0.6, so at 0.4 should be there. So you can see that's correct. Also, if you can now add a surface with electric potential. You can see that this one and the temperature if there's no heat source here. So if we disable it and we do a new study, now the heat is normal again. So if you look at this now and you put in a different color scheme, this one should have rainbow colors now. Rainbow. You can see that they're almost identical. See?
Yeah.
That's because electricity in copper, well, and in some other materials, moves the same as heat.
Okay.
So that's actually also a point. You have to make sure that these two are identical if you don't have a heat source. However, then if, as you saw, if we have a heat source, which is the resistance because we are letting an electric current walk through, and you then calculate it,
it's different.
the heat source changes because this place gets way too hot.
Okay, so when the heat source is enabled, it has the same plot.
But when the heat source is disabled,
When heat source is disabled, it has the same plot of
same temperature as potential.
Electric potential. Okay. Yeah.
And you have to know that you can draw a line like that through. And well, that's about it. If you now follow the slides, I think you'll be okay in that.
Because I don't understand when I follow the slide.
It's a bit of a mess. I also put in a recommendation to him for maybe using an old teacher of mine used Blackboard to film his screen and put it on Blackboard. So I put in a recommendation recommended that to him, so to do this whole thing himself with a microphone and then walk you through the process so you can watch it at home.
That's good. That's good. Great.
That could also even mean the thing what I just had, that the lessons are just for questions.
Yeah.
You can follow the lessons at home.
Yeah.
And it's really, really awesome if you have a if you have an exam in that.
Yeah. So now done?
That's the first assignment actually.
Okay, it's finished now. Just it.
It's just this.
And then how to deliver to the teacher?
Well, wait, and you have to actually put in another thing from the electric potential. You need also a graph like that, like this one. But you know how to do that now.
Let me do it now. Let me start to do it now. 2D plot. Select this one. Surface electric potential.
Yeah.
This.
That one. You want? Where do you want it to start? No, don't drag.
Here.
Just click.
Okay, and then.
And then the other one.
Over here.
Is there.
And then.
Now, you can see already a plot group has been created. See?
Yeah.
Number 7. Click on that.
Okay.
That's it.
Oh, okay.
That's the potential.
Yeah, done. That's it. Finish.
Yeah, and now the whole thing is finished. This is actually everything you have to have.
Yeah, yeah, and then.
This should be enabled, but we didn't calculate it again. So.
So
Then you just save the thing, but I'm not going to save it.
Yeah.
And for convenience in grading, you should call it like this. Your student number, and then opdracht
How
or
to save it?
assignment 1.
Or save it. Just save it and then.
If you want to save something, you can just command start.
Student number and then.
Your student number and then your assignment 1, and then just here the save as. See? It's
Okay.
normal.
Okay. Yeah. Okay. Done. To send it.
To send it leren.saxion